All right, sunshines. Here we go on microproofs, short proofs involving the transitive property, vertical angles, and substitution. So for the first proof, we're given that angle A is congruent to angle 1, and I forgot to fill in this is angle 1, and this is angle 2. So make sure that you correct that on your worksheet. I forgot to mark them, but this one is supposed to be angle 1 and this one's supposed to be angle 2. So it's like the top and the bottom of the hourglass. If you think of, I call these hourglass triangles. This is a really common figure in geometry, especially when we get into our next chapter where we talk about parallel lines. There's a lot of cool properties that happen when you have triangles like this with parallel lines. So I'm given that angle 1, that angle A is congruent to angle 1. So that means this angle is congruent to this angle. And so I can write that in my statements. So statement 1 is going to be angle A is congruent to angle 1. And that is true because it is given. Statement 2, when you're doing proofs, obviously the easiest thing is to start with whatever's given to you. But after that, you need to start looking for information. So I don't know anything about angle 2, and I don't know anything that connects angle 2 to angle A or to angle 1. So I'm going to look for relationships. Well, angle 2 and angle 1 are vertical angles. And we know that vertical angles are always congruent to each other. So I can say that angle 1 and angle 2 are congruent because they're vertical angles. So the more formal way of writing it is that you should, the full text would be to say vertical angles are congruent. But because we use vertical angles so much, it is just generally accepted if you just write vertical angles because everybody in math knows what that means, knows that that's what you care about is the fact that they're congruent. Now I have two statements about congruence. Both of them contain angle 1. Angle A is congruent to angle 1, angle 1 is congruent to angle 2. So since angle 1 is congruent to two different things, those two things must be congruent to each other. Angle A is congruent to angle 2. By the transitive property, which is my favorite property in geometry. You know I'm special because I have a favorite property, but there's a reason I became a math teacher. There's a reason I ask for geometry every year. Transitive property is my favorite property. I love it. I use it all the time. I purposely include it in assignments all the time. Learn it, make sure you know it really well because you're going to see it all the time. So this was the most important proof for today for doing your worksheet. I'm going to do two more examples that are kind of a little lighter that go over, one of them is just practicing with a transitive property. One of them is practicing with substitution like we used to do, long back, way, way ago, like, the week before break. But this is the one that you really need. So you can go ahead and get started on your worksheet. You don't need to watch the other two examples if you're already comfortable with proofs, if this first proof was easy for you to understand. But I'm going to go ahead and go over the other two just so you have them in case you need it. So feel free to just keep watching if you had trouble following that proof. So for this proof, I'm given two statements about the segments. We're given that segment PQ is congruent to segment QS. We're also given that segment QS is congruent to segment ST. We want to prove that segment PQ is congruent to segment ST. And it's already evident just from marking the congruence, marking those congruent statements on the figure. I already ended up marking these two as congruent by marking both of them as congruent to segment QS. And that's really what the transitive property does. So this proof is a super simple one where we just go through segment PQ is congruent to segment Q. That wasn't an S. Segment QS given segment QS is congruent to segment ST, also given. And then again, I have two congruent statements. They both contain QS. So the things that QS are congruent to must be congruent to each other. So PQ, segment PQ, I should be careful with my notation here, is congruent to segment ST. That is, there we go. And then our last one, we're talking about supplementary angles. I could have made this a longer proof by using the word supplementary. This one is a simplified version because it starts out in equation form instead of in that verbal form of stating angle A and angle B are supplementary. But I could have given you that line as the statement and then maybe use definition of supplementary to create this statement. But in this case, we made it easy. We just started out with the algebraic statement so that we don't have to go through that conversion. But what this means is that they're supplementary. So the measure of angle A, plus the measure of angle B equals 180 degrees. Now it's important when you're, again with notation, when you're doing algebraic statements where you're adding and subtracting things, you have that little m in front of the angle sign. When it says m angle, you're talking about the measure of angle. You're talking about the number of degrees that angle is. So it is a numeric value. It is something that you can add and subtract. If you just say angle A and you don't have that m, then you're talking about the physical thing, a physical shape. And so you can't add and subtract a physical shape. It would be like saying pen plus marker. And you're not allowed to do that. You can say the length of the pen plus the length of the marker. So just always be careful. Make sure that you have your m's if you're talking about adding and subtracting. And same thing goes for the equal sign. Equal sign is for numeric values. Congruent symbol is when you're talking about the physical shapes. A length of the pen is equal to the length of the marker, but the pen and the marker are congruent because they are the same length. So for this one, I just copied my given statement, so my reason is given. It's also, this problem does it, and that's acceptable, but it's not my favorite thing to do. I generally avoid naming angles with letters like this. Usually a point is named with a capital letter, and an angle is named with a number. This is really poor notation to do it this way, but I didn't make this problem. So. Maybe someday I'll have infinite time and I will recreate this worksheet and this video and fix this problem to use 1, 2, 3. So again, just given. So if it's given to you, you can copy it into your proof and say it's given and you're good. Now I need to think about why does the measure of angle C plus the measure of angle B equal 180? Well, these two statements look very similar. Something plus measure of angle B equals 180 degrees. Something plus measure of angle B equals 180 degrees. All I did was swap out this measure of angle A and turn it into measure of angle C. We already know that they are equivalent, and I can replace one with the other using substitution. So substitution is used when you have stuff that's equal. You can use transitive property on things that are equal as long as you're taking the whole side. Generally speaking, I usually only use the transitive property if I'm taking a thing. So in this case, these were both congruence examples, so that's where you usually use transitive property. If this had been a statement where I was saying measure of angle A equals measure of angle 1, I still could have used transitive property. But usually, but a statement like this where you have addition, you definitely are using substitution. You cannot use transitive property just to change something out in the middle of an addition statement. And I have seen people use transitive property if you were swapping this whole statement out, but I wouldn't. I generally avoid, I would call that substitution still if you were swapping out an algebraic statement instead of just a single item. And so when you're using substitution, this is the formal way of writing it out, although I like to color code things and just kind of highlight. I swapped out all of this, stayed the same. I just swapped out this with this. And that's just me making notes for clarity. That's not something that's necessary to do when you're turning in work, but sometimes it helps when you're explaining it. And for a more complicated proof involving substitution, sometimes it even just helps me follow along with what I was doing and what I've already accomplished, what I've already used up, because I already made this swap. So if this was a longer proof, I probably wouldn't use that A and C again because I already used it up. And so then I know I need to focus on the other information in my proof. So that's a bunch of examples of really short proofs using the transitive property and substitution, and particularly highlighting the use of vertical angles. Vertical angles are something you should always be looking for. You see them a lot. So always keep an eye out for them because they won't be given to you. It's just in the picture you need to find them.